I am Anil Kumar. Welcome to my series on functions. We will now discuss inverse of absolute functions. We have two examples here. The very first one is to find inverse of absolute function f of x equals to absolute value of x. The other one we have kind of modified is translated 2 units to the right, and we'll find inverse of this absolute function. Now let us first sketch the function. So we'll begin with part A, which is the function f of x equals to absolute value of x. So if you sketch this function, what do you get? You get something like this, right? So I'm going to use rough sketches to illustrate, right? So this is your absolute function. So at 1 the value is 1, right? And at -1 also it is 1. Now we need to find inverse of this function. So one thing is very clear, that if I draw a horizontal line, right? So if I draw a horizontal line, it intersects at 2 points, and that clearly indicates that inverse of absolute x is not a function. Is that clear, right? So if I do inverse of this function, we'll get something like this, which will fail the vertical line test, right? Now let us try to understand how do we find inverse of this absolute function. Well, one method is using graph, right? So we can do it by reflection about y equals to x. So that is one method. We could use this to find inverse, right? So let's do this method. So here, let me make a smaller sketch once again. Okay, so let's say like this. That is the absolute function. When we say reflect about y equals to x, the idea is to find the inverse of the function, right? Let's say to graph inverse. Okay. So as you know, this particular line is along y equals to x itself. So let me just sketch this line y equals to x. Now if I am reflecting on this particular line, then this part remains same, right? Here this part remains same. However, that part which is from -infinity to 0 gets reflected. And so we do get the inverse, right? Which is definitely not a function, right? So this is the inverse of the absolute function, and definitely it is not the function itself. Is that clear to you? Right. Now let's also figure domain and range. So here, what is the domain? Now domain for the function is x belongs to real numbers, and the range is y belongs to real numbers, where y is greater than or equal to 0. Correct? Now when we get to the inverse function, so this side here is inverse, right? So that is inverse function. So inverse of f of x equals to absolute x. This is what we're talking about. So that domain, as you can see now, is x belongs to real numbers, where x is greater than or equal to 0. So this graph is only on the right side. Do you see that? As far as the range is concerned, range is y belongs to real numbers. So as expected, for the inverse, the domain and range swap. Do you see that part? Clear? Right. So these are the basic concepts. You can very clearly see that this one in a darker color here, brownish color, is your inverse function. So that is how you could do it using a graph, reflect the line or the function on the line y equals to x. Now the question is, how do we do algebraically? So let's write algebraic approach. Now to figure out the algebraic method, we can always write f of x as equal to positive value of x for x greater than or equal to 0 and negative value of x for x less than 0, right? For any absolute function. That is how we can define this as a piecewise function, correct? So that really means that to find the inverse, we should work on two pieces. One, when x is greater than or equal to 0, the other one, when x is less than 0, correct? So let's work on these pieces and figure out the equation. So we'll follow the method. For x greater than or equal to 0, we have y equals to x. To find inverse, we'll just swap, right? So we get x equals to y, or f inverse is equal to x. So you see the inverse is same, which is, you say y inverse here is equal to x for x greater than or equal to 0. Correct? Right? Now, what happens for x less than 0? Let's do that part. For x less than 0, we have y equals to minus x. So then the inverse will be minus x. So that is minus x. So this part of the graph is f inverse, which is minus x. Do you see that part? So we get two parts of our absolute function in the inverse, which are as shown here. Right? So that is how we could actually show what the functions are, right? Now, let us try to understand how could we do inverse of absolute function x minus 2, right? I hope with this you got a fairly good idea that we could actually find the inverse using the graphical method or algebraic. Both will give us the same result. Perfect. So let's continue and find inverse of absolute function x minus 2. So let's take it on a fresh page now. Now let us try to understand how do we find inverse of absolute function. Here's an excellent example. We need to find inverse of absolute function f of x equals to absolute value of x minus 2. Well, we'll have different methods to solve this, right? So let's say method 1. In method 1, we'll have table of values. Okay, so what I will do here is that I will write some values for the function itself. So if I have absolute value of x minus 2 for different values of x. So let's say we take values minus 2, minus 1, 0, 1, 2, 3, let's say 4. Okay. So if I substitute minus 2 here, the absolute value will be 4. Minus 1 will give me 3, 0 will give me 2. 1, if I substitute, I get 1 here. 2 minus 2 is 0. 3 minus 2 is 1, and 4 minus 2 will be 2, right? So likewise, we can make a table. Now if I do the same for the inverse, right? So basically we have these coordinate points, right? So now we'll look into the inverse. So as you know, if the coordinate points are, in this case, what are the coordinate points? Let me write down here. So you could actually write these coordinate points as minus 2, 4. So that is minus 1, 3. This is 0, 2. Then we have 1, 1. We have 2, 0, 3, 1, and 4, 2, right? Now for the inverse, we have to swap these points, right? So when you swap, you get the point as 4 minus 2, 3 minus 1, 2, 0, 1, 1. That is invariant point, 0, 2. Then you get 1, 3. And you get 2, 4. Correct. So clearly, we see that, for example, for 1 we have 1 and 3, 2, so that is not a function, right? So from here, it is very clear that inverse is not a function. However, those points define the inverse of the function, right? Now what I'm going to do here is I'll sketch these points. So I'll sketch the graph of this particular function, right? So let's now sketch the graph of the function. I'm going to make some rough sketches. So x minus 2 absolute value, the function itself, we have at 0 it is 2. So at 0, let's say 1, let's say this is 2. And at 2 it is 0, right? So at 2 it is 0. So basically the function is kind of like this. So kind of like this. Is it okay? Okay. So that becomes the function f of x, which is absolute value of x minus 2, right? Now, to get the inverse, these are the points, right? So we have here a point as 4 minus 2. So the value minus 2 is down, right? So which will be kind of like here. 3 minus 1. So at 3, this is 2, right? 3 minus 1 will be kind of here. Then we have 2, 0. So that point is 2, 0. And then we have 1, 1. So 1, 1 will be here. 0, 2 will be there, right? So we get these set of points. And then we have 1, 3. So at 1, we have 3, right? So it goes kind of up, right? 1, 3. And at 2, we have 4. We have 2, we have 4, right? So what we see here is that the graph of inverse function for this particular case will be kind of like this. So that becomes the graph of inverse value. Is that clear to you? So that is the inverse function. Okay. With the points, we can plot the graph, and as you can see, we have the graph of the inverse function. Perfect. Well, that is one method. The second method here is to reflect. So we'll use now the method 2, which is basically reflect f of x on y equals to x. Correct? So let me sketch the line y equals to x. So if you reflect, what do you get? You get your inverse function. Do you see that? So that becomes reflection of this part, and this part gets reflected right there. So we get the same curve. So you could use the points to graph. You could use the reflection to graph. Perfect. So clearly, we could actually get the function very easily by getting the points or reflecting it on the y equals to x, right? Now let's talk about the third method, method 3, let me write here, which is algebraic. Right? So now the value of the function is x minus 2. It can be written as x minus 2 for x greater than or equals to 2, but minus of x minus 2 for x less than 2, right? That is a piecewise function, which we have sketched here in blue, right? This point is 2. Correct? This point is also 2 for us. Now to find the inverse, we have to work in two different intervals, two pieces, right? So let's do these two pieces separately. So let's work in the first piece first, which is y equals to x minus 2. So to find the inverse, we'll swap. So when you swap, you get x equals to y minus 2, and then you isolate, you get y equals to x plus 2, right? So that is one piece. Perfect. So y equals to x plus 2 is actually the equation of this particular part, right? So the positive part. So that is y equals to x plus 2. Clear? Now, let's look into the second part. So this is the first part, right? So the second part here is minus of x minus 2, right? So we have y equals to minus of x minus 2. We'll swap. So first step is swap. So what we get here is x equals to minus of y minus 2. So bringing y minus 2 to, this side. So what we get here is y minus 2, and bringing x to that side, minus x, or y equals to minus x plus 2. Clear? So y equals to minus x plus 2 is this part of the graph, which is minus x plus 2. Clear? So that is the second part, right? So that is how you actually get the value of the function, right? Now, algebraically, that is how you're going to show it. Now, it is important to understand about domain and range. As far as the function is concerned, the domain of the function is basically x belongs to real numbers. As far as the range is concerned, y value belongs to real numbers. However, y is greater than equal to 0. Now, in this particular case, when we are talking about the inverse function, what we notice here is that the domain is now restricted to greater than equal to 0, right? And y belongs to real numbers, right? So here, let me write domain and range in short in the limited space which we have. So domain is now x belongs to real numbers where x is greater than equal to 0. And as far as the range is concerned, y belongs to real numbers is the range. That is for inverse of this mod x. Do you see that? I'm not writing x here since it is not a function. Is that clear to you? But I hope that helps you to understand how do we figure out inverse of an absolute function. So the whole image gets tilted, kind of rotated clockwise by 90 degrees, right? It's kind of like that, right? And translated. So that is how you see inverse of the absolute functions. Right? So net result, which we see normally, is a translation plus 90 degrees clockwise rotation. And translation really depends on the value of this x minus a, right? So that is what is kind of critical. So it's a combination of translation and rotation which gives you the absolute function as you have seen in this particular part of the video. I hope that helps you to understand some basic concepts. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.